So this is a United Stirling P40 Stirling engine. It's a 4-cylinder double-acting engine, so we think it's probably two alpha engines combined.
It's really called a Renia.
Right, okay, so because it's in a ring.
Yeah.
Right, so because it's in a ring and they're all connected up. Fuel source is petrol, and over one side there, so that's
a Bosch Chaotic car system for a 4-cylinder engine piped into one. So for the 4 parts of the injection system are combined into one main injector. The ignition is here, so there's probably a constant source of ignition, although the temperature in there is enough to burn.
So this is probably either a spark or a glow plug, probably?
I've never seen it. I've
never
never
been. Okay.
It probably, it might even, once it's going, stops, and it's, you know.
So we've been having a look at it today to figure out how it works, and there's a lot of things on this one. This one's being geared up for measurement and tests as well. So you've got the fuel coming in this way, and you've got compressed air. This is where it all mixes in. You've got the burner on the top. Somewhere about midway down, we've got these are water pipes. So you've got the cooling, and then everything underneath is all mechanical side with all the pistons, and they're all coming up through. And we've got loads of pipe work to do with water cooling, compressed air, oil,
compressed nitrogen.
We've got nitrogen as well. And we think that there may be some sort of, well, there's definitely some sort of regulation between all the actual cylinders. There appears to be a pump, so it's probably bringing it up to a pressure slowly. I don't know. And then loads of dials here, so you can see all the pressures involved. And then at the back, we've got pressure sensors, or what we believe is pressure sensors would have been. And then there's a whole heap of cables around the back. I'll do some photos around the back, which have got sensors going in, which must be measuring temperatures at various places in the actual engine. So this one, P40 for 40 kilowatt, and there's photographs of this one, this type of engine running a car, so it's sat in the front running a car. It's also had uses in electrical generation in submarines. I'm just trying to think of any other uses. I think there was also some serious work to do with more eco-friendly, probably like methane or some other sort of fuel source.
Or even solar.
Yeah, or even solar, yes. I don't know.
Can we go back to this?
Yeah, let's go back to
this. This is a secondary air supply, which is blown into the burner, and we shall show you a shot of a burner opened up.
Yeah.
So that there's a terrific saving of heat. The exhaust system comes out in these 2 places.
Yeah.
But that goes through a system of storing that heat, which the incoming air to mix, the secondary air to mix with the burn, is already heated up considerably. To get this sort of power output, you need high temperatures, and I would suggest 900 C.
Right. Okay, so about 900 degrees centigrade. Yeah.
And all this is run by an electric motor here before the engine is cranked, so that all the pipe work is up to temperature. This keeps spinning it, and then the engine then is wound by a starter motor to warm the circuits up, and then this then is driven by the engine.
So yeah, so we've got fuel going in, we've got a little bit of air going in for ignition, we've got flow of air, so a big flow of air spinning around, we've got this is so intricate in here, isn't it? Sort of all the shaping and everything in there for the heat transfer. There's pumps and there's even an alternator over there.
That's a Jenny.
That's a generator.
No, that's the power, the engine to spin,
drive that one.
To spin this, and the primary air for the injector.
And
because nothing happens until this is hot enough.
Right, okay. And on, is it the other side there's an off? Yeah.
The
That side's the
alternator
alternator on that
is,
side.
it's basically an automotive engine, so it comes
With,
rigged.
yeah.
It's even got a back plate to take a bell housing on the flywheel, so you might do a photograph of that.
Yeah, we had some photographs. Yeah.
This is inside the burner, very fine finning, and this lot is storing heat. So cold coming in, there are the two exhausts, so this is the heat here is absorbed by this incoming cool air to raise the whole temperature of the burn.
Okay, yeah, so it's basically swirling the air around, you've got the mixture going on, and then it's coming out. So it's, yeah, they've done an
And then
incredibly
if you
good
turn
job.
this round,
Yep.
that is the other side. So this air is coming probably through here and in through to here, where the injector goes. And on top of this is the lid.
Okay, well, I'll just bring this up close to the camera so you see if we can just bring it up. See, it's all shaped. Again.
That's inside, that's where the fire takes place.
Okay. That's the cover that would go
This
on
is
top.
the cover, which is also pretty hot. That coat goes on there and shuts it up. There's a gasket.
Okay. Right. Okay.
So each cylinder is about 275.
275, okay. Nitrogen compressed, and do we know what sort of pressure it was?
Up to £3,000.
So 3000 psi, which then that equates to, yeah, here, so that's slightly over 200 bar. Yeah, incredible unit. Don't get to see many things like this. Okay.